All right, Shama or anybody else playing along at home, we are getting back into Khan Academy to get back into LearnStorm. And what you missed so far is a little video about LearnStorm that I can't show you because it's not my property. But if you go look up LearnStorm Khan Academy, you can probably find that video. I'll even link it on our Schoology because it's a cute little video with Pinky the Brain. And, well, you guys are too young to get that reference. You know the show, like that's why I think he just called it like little Hinky Pinky, like just a Pinky the Brain. All right, so Khan Academy, if you guys remember. Now, back when we were doing this in the fall, we had us versus 3B, right, to make it fair. And it seemed like we kept, like, you know, kind of having the lead. But it wouldn't be fair to start with us having a lead since we're starting a new competition competing for who's going to get a movie like days as we get towards the end of the year, because you can't watch a movie in just one day. So to make that fair, you guys want to drum roll it before we clear it? You can if you want to, I don't care. We're going to clear all our rings and take our progress back to nothing. So starting today, all mastery skill levels that you go up will increase our LearnStorm rings, one for each of us. So before we do that, I got to make sure that we only have the people that are supposed to be here. Excuse me. So assigned to you. I forget how to get where I'm going. You should see angle, angle, triangle, similarity, criterion. Big words. That's what you want to be looking at and like looking through and working through. Then go to the determine similar triangles while I try to update people's usernames.
Did you put these on like in the morning?
Yes.
Because I got a notification from my phone because I have it installed.
Yeah, welcome to I come to work at 7:30 because I'm a morning person.
That's crazy. You know what? I was like,
Just a moment. Let's talk about what we're supposed to learn today, which should take us maybe like 5 minutes, especially because you guys just read through that article, which, guys, anything in Khan Academy that you want to learn, you can. Which is why I wanted us to come back to Khan and kind of do a little refresher. If I wanted to learn about triangle similarity, and I just come to Khan, it'll find me everything related to triangle similarity that I could ever want. Right? You don't have to just be doing what I've assigned to you. And if you want to head on up into the high school math and like entertain yourself with what's coming, if you're like, I'm good at algebra, let's try some high school algebra basics. Like, or algebra 1 or algebra 2 if you're feeling spicy. Like, but what we take in Ohio is the actual integrated maths, but that does algebra and geometry. That's why we call it integrated. So what we're talking about today is angle, angle, similarity. And there's a reason that it doesn't need to be angle, angle, angle. Because mathematicians are efficient. Lazy. But efficient's the nice way to say that. So, Amir, we know that there are two right angles up here, and right angles have to be, like, equal to each other because they're both right angles. But are there any other angles equal to each other, and why? I call it Amir, but if he passes, then we can... Can we spot any other congruent angles, and how do we know? Maybe, but is there any way to know? Like, do we know if we knew A, B, and D were parallel? Sure, I'd agree with you, but do we know they're parallel? Nothing is showing us parallel. Don't think we can figure out that those are equal because we don't know parallel. Nick, got an idea? So let's practice writing these correctly, because especially as we start working in Khan, guys, the other reason why we're going to shift over into Khan is let's say we get to May, and let's say school is over and you didn't get all your homework or your mastery's done. If we're still stuck on paper, you got to do it on paper, bring it to school, drop off the paper, I got to come get the paper, But if we're in Khan and you don't have something done, you email me when you get it done, you say, hey, Hudson, I'm done. I go look at it, I update it, it's done. It's a lot more efficient for the just in case we're not done when the end of but that won't matter for any of you, right? That won't matter for any of you because you're all going to be mastered before the end of the year. This angle right here if we name it using 3-point angle notation, what's the name of that angle? And you can actually call it two different things that are the same thing. And I remember yesterday we've been working on 3-point angle notation. We could call that C, but we can't because there's 4 angle C's. If you look on the outside, also there are 4 angle C's here. So we can't just say angle C. Nope. Nope. Gus?
Like the C apostrophe.
Nope. That's when we move things and it becomes prime. So this is why I hope you're listening right now, because it doesn't seem like any of us remember how to do 3-point angles. Akbar?
Not C.
Simon?
Like, I know D.
So not only was it not funny, but it's not helpful, and I have limited amounts of time. That will annoy teachers the more you do things like that. A, C, B, because if you start at A, drawing the line to C, drawing the line to B, we make that angle. So what other name could that have? What if I go the opposite direction? Start where I ended. BCA is also a way we could name that angle. Always, the C would be in the middle, because it's got to be where the two lines hit each other. What you're naming your angle is like start here, go there, then go there. You made an angle. Yay! Oh,
Could it be DCE?
it cannot, because if I go D, C, E, did I make that angle? No, I made this angle. So Owen just gave us our angle that's down there. What else could we call that one? ECD. Again, with the C in the middle. Now, what could we say about that green angle and that yellow angle, however I call them? And what are verticals? They're congruent, if we want to use the real math word. So this angle, congruent to this angle. Okay, so we knew that these were 90, right, at the 90 degrees. What does this angle look like? And sorry, that's not a plus sign, that's a little angle symbol. So one tick mark here and one tick mark here tells us they are the same. We gave them a coding. We just literally said, like, these are the same. That's what that little one. So then if I wanted to do 2 tick marks, let's say if this angle is equal to this angle, then I use 2 tick marks because you don't always have colors. Right? If you had colors, you could just color code everything. What does DCE look like, or ACB, like 30, 40, 50? Like, what are you thinking? How many degrees?
Which one? 30.
So if we call this angle 30 degrees, what would be left for the blue angle? And if we said that vertical angles are equal, well, this is also 30. Means the other also has to be 60. If you know, let's back this up. If you know 2 of the angles, let's say that 90 and that 30, can the third angle be anything other than what we know it is? No, we know it adds up to what? 180. That has to be true for both triangles. So do we need to find a third angle? No. And this is why mathematicians, instead of saying angle, 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 similarity, except when they're mad, then they're like, ah! A. Okay, I should have written it, then it would have been funnier. But angle, angle similarity is what we call this, so we literally use the notation angle, angle, similarity. So if you see that, like you'll see in Khan Academy, well, you could say angle, angle, angle. It's unnecessary. We just need 2 angles. So check out what I have for you in Khan Academy. If you've made it through the article, go ahead and do that activity. If you have meandered somewhere else, come back. What up, Simon?
So like an outlet to charge.
Right over there by the fridge. You just might have to move the gray cord that's kind of like up there on the counter. Do you need a charger or you have one? I got you. And guys, what's the difference between similar and congruent? Are those two triangles that we just looked at exactly the same? So when we first started learning about similar shapes, how did we define similar shapes, and or what did that article walk you through? Wasn't that the first thing you needed to answer? Even in the article, if it asks you a question, we want to answer that. So which answer would make sense here? What does it mean to be similar in geometry? Well, let's go piece by piece. If all the corresponding pairs of angles in two figures are congruent, then the figures are similar. Well, if we had every single angle is the same as the other, like imagine two shapes, four-sided, every angle is a 90 degree. What shape is that?
Sorry, a square. A square.
Might be.
A rectangle.
It's a rectangle. So hold on. Hold on. So stop what you're doing for a second. Because I'm worried that you guys did not actually answer these questions. Corresponding angles in two figures are congruent and the figures are similar. That, like, it's asking us, right? Okay, I'll make two rectangles so that they both have 90 degrees. Each of those angles is all 90. Are those two shapes similar? No! So what does it mean to be similar?
Could I please have Gabrielle Satoa to the Perry office for a moment? Gabrielle to the Perry
The
office.
two shapes are exactly
Thank you.
the same. They're congruent. So if I do, why'd you do that? Are those two similar?
Mm-hmm.
Yeah. But what's different about them, Beatrix? The size. Guys, similar, Al, I hope you're with me, is same shape, same angles, but different size. But if we start to get into the details, why weren't those rectangles similar? Well, we skewed it, right? One stretched differently than the other. So if we think about similar shapes with like side lengths, it's not like the angles can tell us that triangles are similar. But beyond triangles, you got to be careful. Like the quadrilaterals that we just looked at, all the angles could be the same, and they could still not be the same. Like they might not be similar. Triangles, if the angles are the same, they are similar. Sorry, I also lost 5 minutes off my class plan because if you guys haven't heard, we're doing a tornado drill at 11:30. So I'm trying to quickly figure out how to cover everything I wanted to. All right, so back here. So we said A is not it because we just tried it. And that didn't work, right? Corresponding pairs of angles did not work. If all the corresponding pairs of sides in two figures have equal ratios, then the figures are similar. Equal ratios. A ratio, like what's a ratio? How do we set up a ratio?
1 and 2.
Like compare two things, right? So your other activity here, side, side, side. If we're looking for a ratio here, we have 6, 7, and 7. Compare it to the new triangle, 0.7, 0.7, 0.6. Would A be similar to the triangle I had to start? Why? How does A compare to the triangle I had to begin with? What ratio could we say, Gus? It's 10 over 1 or 1/10, depending on which direction we go. So we not only need corresponding angles that relate to each other, We need corresponding sides that relate to each other with a common ratio. So what about B? 3.5, 3.53? Gus? Is Gus the only one doing this with me? Somebody not Gus, tell me why this is good. He already said it's good. Our original was 677. Why is 3.5, 3.53 good? I can't tell if hands are up or you guys go up and then come back down. Will? And what's the ratio from the original to this one? 2 or 1/2, right? Depending on which direction we go. So that's also similar. Now wait, choose one. Oh, hey, look. If I scroll, now I have the option for both. So please don't blindly just look at one and say, yay, move on, because then kids will come to me and be real mad, and I'll just point at the fact that both is an option. And yeah, then they get mad at me. But really, you can't be mad at me, just be mad at yourself. All right, take a couple minutes. I'm kind of watching what's happening on your screens and seeing. Sort of wanted to do today with like, let's experiment and play with some things, and then tomorrow we can talk more and teach more if we need to. I did set the assignments that you can do them multiple times, right? Okay, so we do need to be trying to get 75 or higher. So if you got only a 50 on an assignment, you need to go back and redo that. And technically, Khan wants it 80% or higher to be mastery. At least I think. Like, we'll figure this out together as we go. But because we've made some progress, like some of us have done a couple activities, I am curious. Do those count towards our progress? Hey. So I wonder how much more we can accomplish in the next like 3 minutes if a few more of you get that angle activity done. All right, so read this. Level up 16 times to unlock the next ring. So when you level up, right, when it tells you you leveled up on this skill,